Managing application workloads in a hybrid cloud world is anything but a simple task. With thousands of workloads demanding various resources, all constantly changing, combined with thousands of cloud templates to choose from to meet those demands off-premises, it all adds up to a multivariate challenge beyond human scale. Cisco and Turbonomic have teamed up to help companies overcome the challenges of a hybrid cloud world, connecting Turbonomic's industry-leading intelligence with CloudCtr's leading multi-cloud orchestration and AppDynamic's leading application performance management. Let's see how they all work together. The first task on a journey to hybrid cloud is to deploy a workload to the cloud. However, which cloud? What zone? What about any policies or constraints? Let's see how Turbonomic and Cisco CloudCtr work seamlessly to ensure the right cloud is matched with our workload. In Turbonomic, we see the entire environment from the application into the infrastructure, and we see a number of possible placement, scaling, and start actions. To deploy a workload, we need a proper initial placement. For example, say our application is medium-sized with some specific constraints, perhaps network. We can find the proper placement, informed by network telemetry from Tetration, as seen here. We can then schedule the deployment or create a reservation, and use the action generated by Turbonomic in CloudCtr to orchestrate the placement. In CloudCtr, this is as simple as checking the box to enable resource placement, and adding resource placement configuration from Turbonomic. Now we can create a new deployment of, say, a WordPress app, simply by choosing this from CloudCtr, then choosing the environment, here called resource, and finally choosing the size we originally identified, medium, and just hit deploy. The application can now be controlled by Turbonomic, and even connected to AppD to access more granular application performance data. Initial placement is just the first step in managing a hybrid cloud workload. Let's look at another application previously deployed to see the importance of continuous tuning of application workloads to match application demand with cloud supply. From the AppD interface, we see another application, webmail, composed of a web tier, a middleware tier, and a database. We see response time spiking at around 1:50 p.m. Increased load is causing significant performance issues across the application, as you can see here in the web and middleware tiers. Switching to Turbonomic, we see that Turbonomic not only sees the webmail app, but understands its entire topology, including the Tomcat and Apache nodes. Turbonomic takes this data from AppD, stitching and correlating it with the rest of the infrastructure. Here, application response time is increased significantly due to the stress being placed on the CPU in the VM hosting the Tomcat node. Turbonomic automatically generates an action to scale the VM to increase vCPU capacity, which we can take by ticking the box and clicking Apply Selected. The action is then executed by vSphere automatically. Returning to AppD, we see the application response time is returning to a healthier state after taking the scale vCPU action. Looking deeper at response time, we see that it is rapidly falling from its earlier peak due to this action. Looking back further, we see the direct correlation between taking action and improving response time. In Turbonomic, we see the VM is now back in a healthy state, returning to green from yellow, due to our scaling action increasing CPU resources, helping satisfy the increased load on the VM. In AppD, we see the same, that everything has moved back to a healthy state. Everything we did here manually can be automated in Turbonomic, enabling the environment to self-manage to assure performance. This is the power of integrating Cisco and Turbonomic technologies to manage the hybrid cloud, making the hybrid cloud autonomic.